Well, welcome back to Heinzel Vision and our next unit, which is current electricity or circuits. A lot of times we can call this unit electrodynamics as opposed to electrostatics, which we just finished. And the word dynamics, if you remember from first semester, refers to things that move because of forces. So we can think of electrodynamics as electrical charge that move because of electrical forces that are acting on them. So let's try to take a basic example of an electric field, a simple electric field, where we have a positive charge and we have a negative charge. If you remember, this would be considered a dipole field, right? Now, the direction of the field is actually pointing from the positive towards the negative. If you remember, it's going to look something like this, right? It's going to go out through space. Now, what I want you to picture here is what would happen if I put an electron in the middle of this field. And I'll use purple for my electron. So, if I put an electron in this field, what would happen? Well, it would be attracted to the positive charge as well as being repelled by the negative charge. So what would happen is you would have a force acting on it in the direction of the positive charge. Now, because of that force, the electron would actually move in that direction. Now, imagine if you were able to take more and more electrons and kind of pump them into this field. You would get more and more electrons kind of traveling through this path, in the direction of the positive charge. This is essentially what happens in a battery in kind of a rudimentary sense, right? A battery, in its most simplest form, contains a positive end and a negative end. And what's really happening inside a battery is the positive terminal has a solution that undergoes a chemical reaction that uses electrons, right? It takes electrons to undergo its chemical reaction. So it's looking for electrons. Think of it as kind of a net positive charge. So it can use electrons to complete its reaction. Well, there's also a chemical reaction happening in the battery tied to the negative end. And this chemical reaction produces electrons. So what we have in the negative terminal of the battery, I'll use some color here, some electrons being produced, some extra electrons from this chemical reaction. And we know they want to get away from each other, and they're going to want to go towards something that needs electrons, towards the positive end. So if we connect a conductor, and let's say through some device like your calculator, what we've really done is we've created an electric field where negative charges can go from the negative end towards the positive end. So what we get is we get electrons kind of pushing through the conductor because the conductor has free electrons in it, so it can allow this path to be created. And they're going to go through the battery. That energy is going to operate the device. And they're going to push through where they go into the positive end and help complete this chemical reaction. So at some point when the chemical reaction is used up, the battery dies and it no longer can produce that electric field. But this gives you a general sense as to kind of the basics of current electricity. We have a positive and a negative end of some kind of source, and we call this a voltage source. Right? The voltage referring to kind of the amount of energy available to push electrons through the circuit. And so that's the general basics as to how current electricity is formed. We have a buildup of negative charge and a positive end that wants to take that charge. And when we connect those through, now the important thing here, this must be a conductor. Copper being the one that we use most typically in our wires to conduct electricity. Then we can create a flow of electrons. And this flow is what we refer to as current. Now notice, if I were to do something like detach this wire, if I were to take this out and I were to break this path, the electrons would no longer have a place to go. They would no longer have a path to flow from one side to the other. So the device that was connected to it would stop working. So if you take the batteries out of your calculator, the calculator needs the batteries for it to operate. They would no longer work.